Hey guys, it's Mr. Telzero, and as promised, I'm going to go ahead and give you guys the rest of the solutions to practice 8.8. It's important that you watch this because at the end there's going to be a couple problems that are new and they will be present on our test. Now, I just wanted to kind of walk through. We solved 1 through 4 in class. You can see number 1 is there. I want to point out that it has a dashed line because we're looking at just a less than sign without the line underneath. Number 2, we had to rewrite our equation as y is less than or equal to a negative x plus 2. We graphed it with a solid line. We found out that the origin 0, 0 did work, so we shaded towards it. Number 3, you can see again we had to rewrite our equation as y is greater than or equal to negative 1/2 x plus 2. We used a solid line. We found out that the origin 0, 0 did not work for our equation, so we graphed and shaded away from the origin. Finally, number 4 was a little weird because we had no y, but all that's saying is that x is going to always be greater than negative 2. We used a dashed line, we did a vertical line, and of course if x is greater than negative 2, we'll shade to the right because 0 would be greater than negative 2. All right, number 5, I'm going to go ahead and set my phone here down so we can look a little more closely and I'll have my hands free, is different. It says solve each system by graphing, and you can see we actually have 2 equations here. We have y is greater than or equal to negative x minus 2, and we have x minus 2y is less than 4. When we have 2 equations like this, we're going to graph and shade for both. Okay, now this first one is going to be easy to graph because it already is set up as our slope-intercept form. You can see that our y-intercept is negative 2, so I'm going to make a dot at negative 2. That's going to be where I start. My slope, there's a negative in front of the x, so that's a negative 1. So that means down 1, forward 1, and that's going to give us our downhill slope that we're going to want. So I just like to put my points, and now I'm going to check. Am I going to have a dash line or a solid line? Because it's greater than or equal to, I will have a solid line for this. I'm not using a ruler because I got to go quick. And I want to go ahead and label. This is y is greater than or equal to negative x minus 2. Now, my next equation is not set up in a slope-intercept form. So I'm going to bring my piece of paper over here and we're going to go ahead and get it set up. All right, I've got my negative 2y right here. I don't like my y to be negative, so I'm going to actually, in this case, add 2y to both sides. And I'm going to rewrite my equation as x is less than 4 plus 2y. Now I'm going to move my 4 over. To move it, I have to subtract it. Now I have x minus 4 is less than 2y. My final step is going to be divide out the 2. Divide out the 2, and then I'm going to divide my 4 by 2 and my x by 2. Now, when you have x over 2 like this, that's the same as 1/2 x minus 4 divided by 2 is 2 is less than y. We're now ready to graph. You can see I have my y-intercept is at negative 2. I'm going to come back to my graph. Now this gets a little tricky because I've already got my other line graphed at negative 2, don't I? But my slope is different. My slope is a 1/2. It's a positive 1/2, so we're going to go ahead and graph that. Positive 1/2 means up 1 over 2, and we want to be uphill. Up 1 over 2, and then I'm going to come 2 back, down 1, 2 back, down 1. And I'm going to check one more time to see that this is just a less than sign. So that means it's going to be dashed. Dash, 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 with my arrows, and I can label my line here, x minus 2y is less than 4. Now, here's where it gets interesting. I've graphed both my lines, but I haven't shaded. To actually find the solution, I'm going to shade both, and wherever it is double shaded is going to be the area that includes the solutions for both systems. So let's start with our first equation, and let's use our friend 0, 0, and we're going to look at this solid line. Let's go back here. If I plug in a 0 for x, I end up with a -2 on this side. And then I have 0 for my y. Is 0 greater than or equal to -2? The answer is yes. So I'm going to shade towards the origin, like this. Now, it's going to be weird because there's this other line here, and that's okay, because we're now going to see which way we should shade for this line. So let's plug 0 in for x and y. Well, that's going to be 0 minus 0, right? Is 0 less than 4? The answer is yes. So for this line, I'm going to shade again towards the origin. Now, what does this mean for us? This means this whole top area is double shaded. I'll even write that on here. Double shaded. Which means everything in this area is going to be a solution to both equations. Okay? Now I want to point out to you 7 and 8, which are going to be questions relating to number 5. It says, is the origin a solution to the system in exercise 5? Well, 0, 0, our origin, is in the double shaded section. So the answer is yes. Now it says, is 4, 0 a solution to this system in exercise 5? Well, let's come to 4, 0. 4, 0 is exactly on the dashed line, which means when it is on the dashed line, it is not part of this system here. So the answer to number 8 is no. And if you're ever in doubt, you can plug 4, 0 in for both equations and find out, does it work for both? Let's try that now. If I plug in 4 for x, I would have -4 minus 2, which is a -6. Is -6 less than or equal to 0? In this case, yes. But what about my downstairs equation? If I plug in a 4, 4x, and a 0, 4y, I'm going to have 4 minus 0, which is 4. Is 4 less than 4? No, it is not. So that is my answer to number 8 is no. In the next video, I'm going to do number 9.